Welcome to Brain Vision.
In this problem, we have an electron moving at a constant velocity, and we're asked to find the magnetic field at 4 different points, A through D. And I've defined the Cartesian coordinate system with x horizontal, y vertical, and z out of the page. We're given a velocity of 10% of the speed of light to 3 significant figures, as well as each position we'd like to find is 2 microns away from the electron. So to find this, we use the Biot-Savart law for a particle with constant velocity, which is B of r is equal to the charge of the moving particle times the permittivity constant multiplied by the magnitude of the velocity over 4 pi times the magnitude of the distance squared, and this is all multiplied by the cross product between the direction of the velocity and the direction where we're trying to find the magnetic field. Now we note for every point in this problem, this whole quantity is a constant, and we can call this B naught. For the velocity, it is, for each point, going to be pointing in the y-hat direction, and the distance to the point we're trying to find the magnetic field, we can write this as cosine of theta r in the x-hat direction plus sine of theta r in the y-hat direction. Now, we know that y-hat cross y-hat is going to be 0, so we only concern ourselves with the x component of this position vector to find the magnetic field, and if we plug in the values for r at point A, we get B of RA is equal to B naught times cosine of 60 degrees times y hat cross x hat. And this evaluates to negative z hat, and cosine of 60 degrees is 1/2, so we can write this as negative b naught over 2 in the z hat direction. And since RB has the same x component as RA, we know that this is also the same as the magnetic field at RB. Now for RC, the position only has an x component, so we can write this as negative B naught z hat. And for RD, this only has a y hat component, and so we can also write that B to RD is 0. So now we have to plug in all of the given values for the distance, the velocity, the permeability constant, as well as the charge of the electron, and with this we get that the constant B naught is equal to negative 1.20 times 10 to the minus 7 Tesla. And this is negative because the charge of the electron is negative, and notice when we plug this into all of these values for BRA, BRB, and BRC, it cancels with this negative sign, and we get that all of these fields point in the positive z-hat direction out of the screen. And we wrote this as with 3 significant figures because that is all the significant figures we are given for the velocity and the distance.